Retrosynthesis is an interesting area of organic chemistry in which we plan a synthesis of a particular target material. In other words, we are given a particular organic molecule and then asked to plan a synthesis until we get to a simple starting material. Just consider an example. We have a molecule which is known as acetaminophen, or we call it paracetamol, with its trade name Tylenol or Panadol. So we have this target molecule and we want to subject it a synthetic route so that we could able to get to the starting material. So we plan a synthesis. Let's we move in backward direction. We call it a retro. Retro means to move in backward direction. We use particular type of arrow which is known as retrosynthetic arrow, which is an open-ended arrow. These tell us about the fragment which are responsible for making these compounds. We also show the disconnection as well by a wavy line. Let me disconnect the molecule between nitrogen and carbonyl carbon. I show the disconnection with the help of a wavy line like this. So this is known as a disconnection. After this disconnection, I get two fragments. NH and these are known as synthons. We call it synthon. Let me place a charges on it, negative charge on nitrogen because it is nucleophilic in character, and positive charge right over here. When we talk of synthon, basically synthon are idealized reagent. They are not exact or true reagent, but they are idealized reagent with corresponding polarities such as positive and negative charges that give us idea about which fragment are responsible for making the target molecule. For example, we call it this synthon as donor. I use D1 for a donor synthon, and this as an acceptor synthon as A1 synthon. Usually when we talk of synthon are two types. There are donor synthon and acceptor synthon. Donor synthon are usually nucleophilic in character, and acceptor synthon are electrophilic. So donor synthon are nucleophilic and acceptor are electrophilic in character. And here we have a synthon which can be a donor or an acceptor. So the number correspond to the position of the atom on which the charge is formed. For example, we can have a different synthon other than these. Consider some example. A hydroxyl group with positive charge. here a negative charge, a positive charge, and a positive charge. So all those synthons which are facilitated with the positive charge are acceptor synthon, they are electrophilic, and as far as the donor synthon, they have a negative charge. So we call the first example as acceptor, and we call it A1, because here if we start numbering, then here we will have a number first. Here this is carbon number 1 and 2, so we call it D2 synthon. Here again this is carbon number first and 2, this is A2 synthon, and here we have carbon number first, 2 and 3, we call it A3 synthon. So these are different type of synthon which can be obtained from different material, organic compound. For example, just take an example of A1 synthon. In the first case, we get it from aldehyde. As far as the next synthon is concerned, usually it is obtained from enolate. The next example is from epoxide. We will check out all these examples later on. Here we are just talking about an introduction to retrosynthesis, and the third example can be obtained from alpha beta unsaturated carbonyl compound. Unsaturated carbonyl compounds. So this is all about synthons. Now let us turn back to the first example. Here we have choose two synthons which are idealized reagents. So the D1 synthon is equivalent for a molecule which is known as para-aminophenol. This is one synthon for the target material, and let me clear it. The second synthon is, as I have positive charge on carbonyl carbon, so therefore I need to attach some halide or electronegative atom right over here. Let me attach a chlorine atom. So this is another synthon or reagent. These are reagent, not synthon, for the target material. So this is how we can subject the starting molecule into a retrosynthesis for getting the simple starting material such as para-aminophenol and an acid chloride. So this logical deduction is known as retrosynthetic analysis. We call it retrosynthetic analysis. Basically, a retrosynthetic analysis is the process of breaking down a molecule into the starting material. The breaking down of a molecule into a simple starting material, simple and readily available material. Readily available material. Consider another example which comes from a herbicide, again an aromatic system. We took chlorine atom, and we subject it into retrosynthetic analysis. Again, we disconnect the molecule right over here, and we get two fragments we call as synthons. As oxygen is electronegative, therefore it is more suitable to place a negative charge on it. So this is a donor synthon, and another we place a positive charge right over here. This is an acceptor, we call it D1, and this is A2 acceptor. So these synthons are equivalent. For example, it is quite easy to predict the first synthon, which is a sort of phenol. So we have the starting molecule like this that come from one synthon, and as far as the second example is concerned, again it has a positive charge, therefore we could have a chlorine atom like this, any halogen atom, or we can have an alcohol group TSOH. We transform it into a good living group, so that once the phenolic moiety is treated with the base, we get a phenoxide ion. This phenoxide ion acts as a nucleophile where it performs an SN2 type reaction on this carbon atom, which is alpha carbon atom. So here an SN2 reaction take place. For example, let's me call it A, and if I consider the forward synthesis, I will react A plus B in the presence of some base to get a phenoxide, and then I will get a product C. So this is a forward synthesis for this reaction. So this is a simple introduction to retrosynthesis. Here we need to call it CO ether disconnection, or we call it CO ether disconnection. Just consider the important aspect of retrosynthesis. In retrosynthesis, usually we plan a synthesis of a particular target molecule. For example, we have a target molecule in the starting example, which is paracetamol. We plan its synthesis. First, we consider a synthon, which are idealized reagent. These synthons are acceptor and donor in character. Especially when we talk of synthon, we usually consider a polar reaction that take place between a nucleophile and electrophile. We have also given some example of different synthon and consider different material that are responsible for generating these synthons, such as aldehyde, enolate, epoxide, and alpha beta unsaturated carbonyl compounds. So these are different starting material for this synthon. And as far as the retrosynthesis or retrosynthetic analysis is concerned, it is the imaginary process, especially a paperwork which is the breaking down of a molecule into simple and readily available material. Thank you for watching the video.